we're going to look at limiting reactants and see how we calculate limiting reactants and products and percent yield, all the stuff in this unit. We're going to do it all together now at once. So here's the problem that I'm looking at today. Aluminum oxidizes according to the following equation. I have 4 aluminums, reacts with 3 oxygens to form 2 aluminum oxides. Right? I'm told that powdered aluminum, 4.8 grams, is placed into a container containing 3 grams of oxygen. I want to know what the limiting reactant is and how much aluminum oxide is produced. So I have 2 problems to do here. Let me identify first here that here, this is one of my givens, right? And here is another one of my givens. I am asked about aluminum oxide, so that's what I need to find. So I've got 2 things to do here. I'm going to start with 4.80 grams of aluminum, right? That's this. And I'm trying to get to aluminum oxide, so I'm trying to go there, right? My balanced chemical equation is a mole ratio. 4 moles of aluminum reacts with 3 moles of oxygen to produce 2 moles of aluminum oxide. I'm going to use that mole ratio, but I have to convert my grams to moles first. So I have to make use of my molar mass. Right? I look up aluminum on my periodic table, and it's 26.98 grams per mole of aluminum. Right? That's just right off there. I don't look up here to find this. When I look up the mass off the periodic table, I want the mass of just 1 mole. Because if I use this 4 here, then that means I have 4, and I'd have to multiply by 4. And so if I have 4 over 4 times that, that would just cancel out. And so that's a waste of my time to go and multiply that by 4. So just the molar mass of 1 mole is all I need to do this problem. So 4.8 grams times 1 mole over 26.98 grams. And I do that so that my units will cancel out here. Okay? Then I need to continue on. I now can make use of my mole ratio. Right? I have aluminum already, so I'm going to put this in here this way. I'm going to put the 2 moles of Al2O3 up on top and the 4 moles of aluminum down on the bottom so that this unit here cancels with that unit there. I'm asked for the mass here, so I'm going to do that next. I need Al2O3. Right? I know I'm going to use 1 mole of Al2O3, but I need to get the mass there, so let's add that up. 26.98 times 2 plus 15.9994 times 3 gives me 101.96. 101.96 grams of Al2O3. And I wrote that again up there because when I cancel this out with this one, I don't have anything left telling me what it is. So I'm going to put that up there so I can keep those units at the end. And then I plug it in my calculator. 4.8 times 1 doesn't change anything, so I can do that on my head. And then that's a fraction, so divided by 26.98. I'm going to multiply that by 2 divided by 4 times 2 divided by 4, and then times the 101.96. And I can divide by 1 in my head, so I'm just going to hit enter there and get my answer. 9.06 grams of Al2O3. All right, that's the first problem. The next one, I have to use my other given. 3.00 grams of oxygen. I'm going to convert it to moles. 1 mole of O2 is 32.00 grams, right? 16 times 2 for those. And now I've got a different mole ratio. Now instead of this one, I need this one. So I'm going to use the 3 moles of oxygen and the 2 moles of Al2O3. And so this is going to be 3 moles of O2 down there. The end of this looks the same, so I can use that mass right there. 101.96 grams of Al2O3 per mole of Al2O3. Now, those are the same because I have to know if I'm going to calculate how much aluminum is produced, or aluminum oxide is produced, I need to calculate the same thing from both of these so I can make a comparison, right? And so that's why I've converted to the same thing. That's one way to check when you're doing a limiting reactant problem. You want to make sure that you're converting everything that you're given into the same thing so that you can make a comparison of those products. So let's plug this one in. Here I've got 3 grams, right, divided by 32.00 times 2 divided by 3 times 101.96, and I get 6.37. 6.37 grams of Al2O3. So when I look at this, this is the smaller number, right? So this is how much aluminum oxide I can produce. I can produce this much aluminum oxide. My limiting reactant, though, is a reactant, so I have to look back over here. It's the oxygen that gave me this lower value of aluminum oxide, so I run out of oxygen after I've made this much. Even though I have enough aluminum to make more, I only have enough oxygen to make this much. And so that's my limiting reactant. My limiting reactant is oxygen. Okay? How many moles of the excess reactant remain? Okay, well, I have to figure out how much aluminum I actually use. So I'm going to start with this. I have 6.37 grams of Al2O3 that I made and collected here, right? And so I'm going to then convert this to moles, right? 1 mole of Al2O3. Notice it's kind of the opposite of this, right? I've got 101.96 grams, right? So that these units cancel out. I have a mole ratio of 4 moles of aluminum for every 2 moles of Al2O3. And I have to convert that back to grams. It's 26.98 grams of aluminum for every 1 mole of aluminum right off the periodic table. So again, I can check myself by seeing that the same units cancel off top to bottom as I move left to right. And I can plug that in my calculator. So 6.37 divided by 101.96 times 4 divided by 2 times 26.98 equals 3.37 grams of aluminum used. Okay? Now, I started off with 4.8 grams, right? So 4.80 grams minus 3.37 grams, right? 4.80 minus 3.37, right? I get 1.43 grams of aluminum left over, right? Now, let's suppose for a moment that I collected 4.5 grams of aluminum oxide. What is my percent yield for this reaction? Right? So what I'm saying is this is the amount that I was actually able to collect. This part up here, this part that's left over from the limiting reactant, tells me how much the math says I should be able to get. But this is all I was able to collect in lab because some stuck to the filter paper or some rinsed through because it was too small for the filter paper, something like that. But I wasn't able to get all that was possible to be made. So I can calculate a percent there. The 5.45 grams of Al2O3 is my amount that I collected. The maximum possible is what the math tells me, 6.37 grams of Al2O3. I divide those, the part over the whole, times 100 to get the percent. And so 5.45 divided by 6.37 times 100 equals 85.6%. Okay, now that's how you do these types of problems. That's all that there is to it. I hope that helps.